Grade 9s, today we will do questions related to quadrilaterals and all the properties we discussed on Wednesday. I hope you have a clearer understanding of all the shapes and their properties. It's no longer a square is a side with four equal sides. As you can see, there are many other facts about a square that you came across on Wednesday. Now I'm going to walk through two questions with you in this lesson. So let's go through it, and then again you will have a few questions to do. And remember, there will be a quiz opening today based on what we have done thus far. Right, when you have a question like this, now the diagrams look quite scary because you have more than one shape in the diagram. But please, all I suggest is read the question and mark the properties on the diagram and you'll have no problem. So let's look at it. ABCD is a parallelogram. So straight away I'm going to take my highlighter and highlight that shape, ABCD. And with a parallelogram, without reading further, I'm going to mark the properties of a parallelogram. Opposite sides are equal. Excuse me. Opposite sides are parallel, and we know that opposite angles are equal. Okay, it'll look too complicated if I add more, but for now that's enough. Calculate with reasons the size of D1, D2, B2 and B3. Now there's D1 here. Now D1 is in this little triangle ABD. In geometry, when working with geometry, please get into the habit of naming the triangle, for example, that you're working with. So in triangle ABD, we know that the interior angles of a triangle add up to 180 degrees. We have two of the angles. Now this little square here means it's a right angle, meaning B1 is 90 degrees as given in the question. And I'm sure you know that the square represents 90 degrees. That angle can be found because we have two of the three interior angles given. So we can say that angle A, which is 70, plus angle B1, which is 90, plus angle D1, which is unknown, add up to 180. And reason? Interior angles of a triangle. Then you solve for D1. D1 is 180 degrees minus 70 minus 90. And that is equal to 9 and 7, that is 20. So D1 is 20 degrees. Okay. Now, D2, where is D2? Now, if you look carefully, this line is parallel to that line. So there's our Z formation. I'm not sure if you can see it. Let's highlight it. There's our Z. So that angle and that angle will be equal. Alternate angles. So D2 is equal to B1. And the reason is alternate angles. Why are they equal? Because line AB is parallel to CD, as stated in the question. Now remember, if you did not mark that line parallel, because it's a parallelogram, you wouldn't see that. So that is why it's important. It's a parallelogram, so it's given that those lines are opposite lines are parallel, because it is a property of a parallelogram. Therefore, D2 is 90 degrees. Right, moving on to the next question. Next part of the question, B2. Where is B2? B2 is lying here. Now that line is parallel to that line. So there's another pair of equal angles, alternate angles. If you look carefully, there's the Z in blue. So we worked out D1. So D1 is equal to B2. So B2 is equal to D1. What's our reason? Alternate angles. Why? Because AD is parallel to BC. It was given that ABCD is a parallelogram. Okay, so B2 will be 20 degrees. It was worked out there that D1 is 20 degrees. Okay, now moving on to B3. Where is B3? B3 is over here. So if you think about it, how would you work out B3? There are many ways. You might get to these angles using other methods. That's fine as long as it's mathematically correct. So how would I work out B3? If I look at it, ABC is a straight line. We don't know that those lines are parallel as yet, so I would say B1 plus B2 plus B3 add up to 180 because it's a straight line, angles on a straight line. Therefore, B1 is 90, B2 we just worked out as 20, and B3 is unknown. So therefore, B3 is equal to 180 minus 90 minus 20. And that is equal to 70 degrees. So 70 plus 20 is 90, 90 plus 90 is 180. And that gives you question 1. Now, after all that calculation, let's look at question 2. You're probably wondering, what is the point? You're obviously going to use those answers to work at question 2. Now they want you to prove. Now please remember, this word means you have to show it's a parallelogram. It is not telling you that BECD is a parallelogram. So right now, all we know is that it is a quadrilateral because it has 4 sides. But they want us to show that it is actually a parallelogram. Now if you go back to the properties of a parallelogram, you could prove any one of the properties to show that it is a parallelogram. You don't have to prove all of them. And if you look at your question 1, by using your angles, you are able to show that lines are actually parallel. So let's look at it. I want to fill in whatever we calculated. So we worked out B3 was 70 degrees. We worked out B2 is 20. We said D1 is 20, and we worked out that. Did we work out C2? Now C2 is 70 degrees because it's equal to A. It's opposite sides of a parallelogram. And you can clearly see what's happening here. That is 70, and then this would definitely be 90. Interior angles of a triangle. It's the same triangle. Now what does this show, class? This shows that because this angle is equal to that angle, that line has to be parallel to that line. And because this angle is equal to that angle, this line has to be parallel to that line. You agree? So that means that and that are parallel, that and that are parallel, which means BECD is a parallelogram because opposite sides are parallel. And that is one property of a parallelogram. So let's write it down. How would you write this answer down? You'll start by saying that B2 is equal to C1. It's already calculated, and so you can just say proved. It's proven in the previous question. And then you know that C2 is equal to B3. Proved. Okay. Now, therefore, because B2, so maybe I should write this first. If B2 is equal to C1, you can say that BD is parallel to EC. Why? Alternate angles are equal. And because C2 is equal to B3, you can say that BE is parallel to DC because the alternate angles are equal. Therefore, BECD is a parallelogram. That's the abbreviation for parallelogram. And number 3, prove that the same shape is now a rectangle. Remember, a rectangle is a parallelogram because both pairs of opposite sides are equal and parallel. The difference is a rectangle has a 90-degree angle, and it's already proven here. We've worked out D2 is 90, angle C will be 90 because those lines are parallel, co-interior. Angle E is 90, interior angles of a triangle, and there we go. Angle B, this part is 90, 70 plus 20. So why is it a rectangle? Because D2 is equal to C, is equal to E, is equal to B, all equal to 90. So that's B2 plus B3. Therefore, BCED is a rectangle. Okay, lots of theory came out in this question. So you had to know your properties to answer this question. Right, let's go to the next example. This example involves a kite. I've chosen a kite because very often learners get confused with the properties of a kite. So let's look at it. Again, if you recall what I said to you, read the question. And the first statement is saying that that is a kite. So let's mark all the properties first before we do anything else. If it is a kite, we know that those angles are 90 degrees because that's a property of the kite. We also know that that side and that side are equal, and this side and that side are equal. Now we know more about it, that the angles are equal, but right now we mark the properties as we need them. Okay, now we know that BD is also bisected. Now they gave us something here. BD is 30 centimeters. If BD is 30 centimeters, that means BE will be 15 and ED will be 15. So from here to here is 15 and from here to here is 15. Because that side of a kite is bisected by that diagonal as per the property. Now AD is 17. It was given that AD is 17 centimeters. BD is 30 and DC is 25 centimeters. Determine AE. So now you're working with lengths. When you're dealing with lengths and a right angle triangle, the theorem that comes to mind will be the Theorem of Pythagoras. So where is AE? AE is part of the triangle at the top here. So if we highlight that triangle that has AE in it, you can use that one or you could use the other one. So I've chosen to use that one. Again, name the triangle you're working with. So in triangle AED, what do we have here? It's a right angle triangle. So you need to state firstly that E2 is 90. It wasn't given. All that was given was that it's a kite. And you can just say property of kite. Then it's understood that you know that that is one of the properties. Because A2 is 90, you can therefore use Theorem of Pythagoras. We also have to say ED is 15. ED is 15. It was not given. You work that out because you know that that diagonal is bisected. BE is equal to ED. It's a kite. Again, it's a property of a kite. So you could write it out like that. Or you could say property of a kite. Therefore, in triangle AED, you're going to use the Theorem of Pythagoras to find AE. So AE squared, and if you remember the Theorem of Pythagoras, the hypotenuse side is given. So you don't need to, you will have to subtract. And your reason here is Pythag. And that gives you 17, that's 289 minus, so that is 64, I think. Therefore AE, which will be 8 centimeters. Okay. Then you have question 2. Question 2 is asking you for AC. AC is the other diagonal. So in order to find AC, I need EC. So now you need to work with the triangle below. So I'm going to highlight that in blue. Again, you will use the Theorem of Pythagoras and you will work out EC. So in triangle EDC or DEC, however you want to call it, you need to say that E3 first of all is 90 degrees, property of a kite. Or you could say adjacent supplementary, because we already stated there that E2 is 90, so obviously that will be 90 because it's on a straight line. Therefore, we want EC squared is equal to DC squared, which is 25, minus DE, which is 15. And again, that's Pythagoras. And what is 25 squared? 625 minus 225 is equal to 400. So EC is equal to the square root of 400, which is 20. centimeters. Therefore, AC is equal to EC plus AE. That's 20 plus 8, which gives you 28 centimeters. Right, so a lot of Pythagoras calculation came up in this question. And one more is question 3. Calculate B1 here if A1 is 20. Now, in triangle, so B1 is part of triangle AEB. You've got E1, you've got A1, so you can work out B1. So again, in triangle AEB, E1 is equals to 90. And you can say property of kite, angles on a straight line, any of those. And then you can say angle B1 is equal to 180 minus 90 plus the 20 given. Interior angles of a triangle, and that is 180 minus 110, which is 70 degrees. Right, and that's all you do, grade 9s. You just have to know the properties of your shapes. As you can see again, if you didn't know the properties of the kite, you wouldn't know where to start with this question. So learn the theory behind the properties, please. Okay, have a good weekend. Bye-bye. Don't forget to do your quiz and submit on time. And please read the instructions as to how you submit. A lot of you messed up quiz 1. If I say numerical value only, it means do not type in x is equal to. It means you just put in the value, please. Okay, bye-bye.